Okay, hi everyone, welcome back. We are still in Module 2, Topic 3. We're in Lesson 1. We are in Activity 2, which is pages 306 and 307. Using double number lines to convert units. So when we use a double number line, we can use those to represent ratios, and we've been doing this. We had it on our last test. We had it on the test before that. Let's move this cord out of the way. Okay. It says when you learned about ratios, you learned how to use double number lines to determine equivalent ratios. You can also use double number lines to convert from one unit to another. Many rulers are set up as double number lines. You can use this type of ruler to convert between inches and centimeters. So it says label the scale that represents inches and the one that represents centimeters. So the top here is centimeters and the bottom is inches. And how do I know that? I know that because centimeters are smaller than inches. Okay. Can you think of other real-world examples of double number lines? We've had a lot of those. We don't need to go over that. We kind of had a lot of those even in the last unit. Okay, use the ruler as a double number line to determine each approximate conversion. So I think the first one is the hardest. 1 centimeter is about how many inches? Let me see if I can zoom in on this here a little bit. I'm going to move my paper over. So 1 centimeter is right here. If I follow that down, it's here. So we need about what fractional part of a inch that is. It's less than half of an inch. I'm going to have you mark that as about 0.375 inches, please. Okay, then 1 inch is about how many centimeters? So back up here, we have our 1 inch. And that goes up about here. So that is about 2.5 centimeters. And then we have 5 centimeters is how many inches? So if we look at 5 centimeters, remember this is the centimeter side, not here, this is inches. 5 centimeters is about 2 inches. Okay, moving on, let me zoom out a bit. And we'll flip the page. Nope, we'll go to the next page. I need to grab the next page. Okay, and here we go. So because most conversions compare two quantities, we already did this. I grabbed the wrong page. Let me pause for a moment. Okay, here we go. I am now on page 307. You're baking cookies at your friend's house. You cannot find the measuring cups, but you can find the tablespoon. So it says use the double number line to determine how many tablespoons you need of each ingredient in the recipe. So it's going to take a lot of tablespoons to give us 2 cups of sugar. So using this double number line, I'm going to try to add some additional information here to kind of help us out along the way. So if we look at this, it is broken up into groups of 16 here. If I counted 1, 2, 3, 4, 5, 6, 7, 8, this line that's a bit longer here is 8 tablespoons. It's directly across this one, so halfway between 0 and 1 cup would be, so this is half a cup right here. And then we could continue here. So here's 1 1/2 cups, and this is going to be going up by 8s. So we will have 24 tablespoons, and then here we have 32 tablespoons and 2 cups. Okay, so 2 cups of sugar is going to be 32 tablespoons. That's shown with a capital T. Okay, now it says 1 3/4 cups of flour. Well, 1 3/4 is going to be past the 1 1/2 and halfway between 1 1/2 and 2. So if it's broken up into 16s between here and here for the whole cups, then we know it's 8 for the half cup. So halfway between the 1 1/2 and the 2 will be the 1 3/4. So 1, 2, 3, 4, and that matches with here. So this is where 1 3/4 is. So if these are going up by 8s between here and here, then that will be 24. So let's see, 25, 26, 27, 28, 29, 30, 31, 32. So 24, 25, 26, 27, 28 will be right here. So 28 tablespoons. Pause as you need to get that labeled, guys. Okay, half a cup of raisins is right here at 8 tablespoons. That one's fairly simple. Suppose you had found the cup but not the tablespoon. So now it's saying we're going to do it the other way around. How many cups will you need if the recipe calls for 2 tablespoons of vanilla extract? Now, this one, you wouldn't ever use it like this because it would be nearly impossible to measure an exact amount using a 1 cup measuring cup to get a portion of the cup. But let's just answer it anyways. So 2 tablespoons would be right here. So this is 2 tablespoons. So we need to figure out what measurement is right here. So if it's going up by, there's 16 little ticks here. So this would be 1/16, and then this next one would be 2/16, 3/16, 4/16, 5, 6, 7, 8/16, which is the same as a half. So my thinking is correct there. So this is 2/16. So this is 2/16 right here, this second line in, which is the equivalent of 1/8. So this would be 1/8 of a cup. You need to measure your room for new carpeting, paint, and border on the walls, but you only have a meter stick. You need to know the dimensions in feet to purchase materials. You record these measurements. The length of the room is 5 meters, the width is 4 meters, the height is 2.5 or 2.5 meters. Create a double number line and use it to convert each dimension to feet. Let's see if my ruler is readily handy. I'm going to pause. Okay, so we're going to start a double number line. I just drew 2 straight lines across. I'll probably try to give you a paper that has a double number line in class, or just have you use a straight edge and draw 2 straight lines here. So it says create a double number line and use it to convert each dimension to feet. So let's see, so we're going to have meters. So we need meters and feet. And it says, remember, 1 meter is about 3.28 feet. So we'll just start here. We'll say 0 meters is 0 feet. And then, oh, I am so sorry about that. Okay. We are going to space this out then. I'll say this is 1/2 of a meter. Move it over a little bit. And then we'll do 1 whole meter, 1 1/2, 2, 2 1/2, 3, 3 1/2. I'm not sure how far we need to go out here. Looks like we need to go to 5 meters. 4, 4 1/2, 5, and I'll just go out to 5 1/2. Okay. So then here on the other side, try to make these all about the same length. Okay, so it says 1 meter is about 3.28 feet. So 3.28 is right here. So then 2 meters is going to be double that. So that will be 6.56. Add 3.28 to that for 3 meters. Actually, it doesn't even ask us about 3 meters, so I'm going to go right up to 4. So 4 meters will be twice this. So that will be 13.12. And then add another meter to here. So the 3.28 feet, 1 meter plus 4 meters equals 5 meters. I'm going to try to get to here. So 3.28 plus 13.12. I literally just turned the volume off and there it goes again. Okay. And that is 16.4. Okay, so let's see if we can answer this. The length I kind of wrote right where I need to. So the length of the room is 5 meters. I'm going to put my answers right up here. So that'll be 16.4 feet. 4 meters, I figured out, is the 13.12 feet. And 2.5 meters, okay, so we still need to figure that one out. It's here. So half of a meter, so 3.28 divided by 2 for half. I want to model kind of a division of decimals for you. 1 times 2 is 2. 3 minus 2 is 1. Bring down the 2. Notice I put my decimal point straight up. 2 goes into 12 6 times. I subtract, I get 0. Bring down the 8. There are 4 8s, 4 2s and 8. So 1 64 hundredths is the half. So I need to add 1.64 to the 6 56 hundredths to get my 2.5. So 6.56 plus 1.64. 10, 12, decimal point stays in line. 8.2 feet. Okay, again, pause as you need to. Zoom in on your iPad if you need to see this a little bit more. I'll zoom in on it right here. And maybe you can pause right there to get it copied down. Okay, moving on though. Oh no, that takes us to activity 3. We'll see you on the next video for that one.